So we're going to be looking at the four main types of geometric transformations. Before we look into them, though, we need to first talk about this word isometry, which means rigid motion. And isometry is a transformation that preserves, it keeps the length and the angle measure of a shape the same. So if a shape is transformed and yet the shape has not actually changed, it's just moved, then it's considered to be isometry. It's considered to be rigid in that transformation. So if we look at this image here, this is our pre-image. And the reason it's called pre-image is the same reason why we call something that happened before history was written down as prehistoric. It is what came before the event started happening. So the pre-image is the image before the transformation is applied to it. In this pre-image, we call it A. Once we apply a transformation, it's no longer the pre-image, it is the image. It is what has happened after the event, the transformation has been applied to it. And the way that we're able to see that it's no longer the pre-image is because we have this little prime symbol with it. This is A prime. This is what happens after the transformation. Now as we look at these two images, we can see that they're about the same size. This blue one is just facing in a different direction. And so we can see that this most likely is an event of a rotation that has been applied to my image. And so because the only thing that happened to it is a rotation and the shape itself has not changed its size, then this is a rigid motion. The lengths of the shape have been preserved, the angles are still the same, it's just facing in a different direction. So if we look at another example, we can see again, this is my pre-image and then this brown one is my image. You go from A to A prime. The shape is still facing the same direction, but the shape looks like it has gotten smaller. The shape has undergone a dilation, and so because the shape might still be facing the same direction, it might still look the same, but because the lengths have not been preserved, the brown one has shorter lengths than the green one, this is a non-rigid motion. So if we start with our first type of transformation, we're going to talk about the reflection. A reflection is the flipping of an image equal distance across a line. It's taken this triangle that was in the lower part of my coordinate plane and reflecting it across this blue line of reflection. This is a rigid motion type of transformation because the triangle is completely identical, completely congruent to the original one, but it is just in a different place, a different orientation. It has been flipped, but the shape is still preserving its lengths and it's still preserving its angles. So if we look at some properties for it, the first thing we can say is that the reflection line, this blue line right here, is a perpendicular bisector of the line P to P prime. So what it means is once we've done this transformation, once we've reflected this triangle, if we look at what is the pre-image and we look at what is the image following based on how this diagram is laid out, if we draw a line from a pre-image point to its prime point, this line that's connecting them, the line of reflection is perpendicular to it, so it makes a right angle, and it's a bisector. It's perfectly cutting this line in half. So this total distance here is 6, but it's 3 on the top side and it's 3 on the bottom side. The points that are on the line of reflection are the same. The pre-image is the same as the image. So if we look at point B, if we reflect point B, it's already on the line. It has 0 distance away from the line, so reflecting that is going to keep it 0 distance away from the line. So B is going to be the same as B prime. And then notation. So a way that we might see reflection notation is looking at XY, so my original point. So if we look at P again, 4, 3, the reflection applied to it results in X negative Y, which just is another way of saying changing its sign. So 4, 3, if we apply this reflection to it, becomes 4, negative 3, giving us our prime P value. And we can see that with all of the points here. So Q, 0, 1 goes to 0, negative 1, negative 1, 3 goes to negative 1, negative 3, and this entire triangle is mirrored below the line of reflection. It also has equal distance across all of the points. So if there's 1 unit of distance here, there's 1 unit of distance there. There's 3 here, there's 3 on top. They're equally distant away from that line of reflection. So if we look at the rules for reflection, first looking at the x-axis, for any point that you have, if you reflect over the x-axis, that point, the y value will change its sign. For going over the y-axis, for any point that you have, the x value is going to change its sign. And if you're going over y equals x, your coordinate, whichever coordinate you're looking at, is going to flip its positions. Y becomes the x value, and x becomes the y value. And then if you're reflecting over y equals negative x, it's going to be the exact same thing as y equals x, but they're going to change their sign as well. So if we look at an example, we're going to look at the point 2, -3. So if we take 2, -3, and we reflect it over the x-axis, the y value is supposed to change. So 2, -3 would become 2, +3. 2, -3 over the y-axis, the x value is going to change. So 2, -3 becomes -2, 3. Reflecting over y equals x, we're supposed to swap the positions of y and x. So 2, -3 becomes -3, 2. And lastly, going over y equals negative x, 2, -3 becomes +3, -2. So swap them and change their signs. If we want to see this visually, we're going to take the point -1, 4, and we're going to reflect it over all 4 lines of reflections and write the rules for it. So if we're going over the x-axis, we're going to take -1, 4 and reflect it over that horizontal line going left to right. So -1, 4 would become -1, -4. The y value would change. And then we see that the distance from the original point to the line is the same distance as the line of reflection to the new prime point, the image. If we go over reflecting the y-axis, reflecting over the y-axis, -1, 4, we'll be going over the vertical line, and it's going to become 1, 4. The x value is going to change. And again, that distance from the pre-image to the line of reflection is the same distance as the image, the prime image, from that line of reflection to itself. It's 1 on one side, it's 1 on the other side. If we're reflecting over y equals x, -1, 4 is going to go over the positive diagonal line, and we're going to swap its values, so it's going to become 4, -1. And again, we can see that the distances between these 2 points is equal on both sides of the line still, even though it's at an angle, and we can very clearly see from this diagram that it's perpendicular on both sides of the line. Then if we're going over y equals -x, it is the downward slanted diagonal line, and we're going to swap and change the sign, so it becomes -4, 1. So those are the 4 types of reflection rules that we can see and just be able to apply the rules to them, but there are other types of reflections out there. So what if we're told to reflect this point, -1, 4, over x equals 2? Whenever you're told that you're reflecting over a line and it's x equals a number or it's y equals a number, you need to go to that number and then draw a line through it. So x equals 2 means that we go over to where x equals 2 is at, this line here, and we draw a line through it. And so then we have to remember, okay, well, we might not have a rule necessarily to go over x equals 2, but we do know the properties of what reflection does. Reflection takes an image, and whatever distance that image is away from the line of reflection, it copies it over to the other side. It mirrors that same distance to the other side. So if we look at my point, -1, 4, that point is 3 units away from that line of reflection. So if that's the case, then I need to take my point and I need to take it again another 3 units in the opposite direction. So then 3 more units up from x equals 2 is going to be 5. So my point is going to end up being 5, 4 once I do this reflection.